Hello, my name is Caitlin Powell. I am a sophomore mechanical and aerospace engineering major here at Oklahoma State University, and I am the 2019 AIAA High Power Rocketry Team Director. Today I am here to introduce the OSU Rocketry team's submission into the 2019 Argonia Cup. Since our team's creation in the fall of 2016, we have competed twice in the Argonia Cup, winning first both times, as well as attending the Spaceport America Cup in Las Cruces, New Mexico, the past 2 summers. The Cloudbusters are looking for a collegiate team to master their challenge of taking a golf ball payload to 8,000 feet and returning it to a predetermined site just off the location of the launch site. The team who is able to reach the minimum apogee, who recovers their payload closest to the predetermined location, and has a successful launch with a reflyable rocket will win the competition.
Hi, I'm Tim Reynolds. We'll be using dual deploy on our rocket for a safer, more reliable, and proven recovery system. We've had previous successes with the design that we're using, except now we are downscaling it both in size and weight. We feel this is the safest design overall throughout the 3 stages of flight. Our rocket is 3 inches in diameter, about 5.5 feet tall, and will weigh about 11 pounds on the launch pad. We will be expecting an apogee of 9,400 feet. We will be launching on a CTI 740K C-Star motor. This produces about 198 pounds of thrust on liftoff. This gives us a thrust-to-weight ratio of 18. This high thrust-to-weight ratio allows us to reach our altitude and helps prevent weather cocking at takeoff.
Hi, my name is Cole Henderson and I'm with the structures team. This rocket is scratch built from commercial composite fiberglass tubes and 1/8 inch fiberglass sheets for the centering rings and fins. We assembled this rocket using G5000 rocket epoxy. And we designed this rocket using a stability factor of 1.5 to ensure that the rocket is stable, but not so much that weather cocking affects the ground distance traveled. We recently acquired a 4-axis fiber winder, but its application has yet to be determined. And normally we hand wind our own tubes, but due to the strict tolerance levels, we felt that commercial parts would be more suitable for this application.
Hi, my name is Lucas Utley and I'm leading recovery operations on this project. We're using redundant dual deployment altimeters to control the recovery events of not only our rocket, but also the golf ball payload. We're using a telemega as our primary altimeter to deploy the drogue parachute at apogee and our main at 600 feet. We're also using an Easy Mini to deploy our drogue at apogee as well, and then a main parachute, the same one, at 400 feet. Our main parachute is a 60-inch nylon chute, and then our drogue is a 10-inch nylon. It gives us a descent rate of about 148 feet per second, which is rather steep, but we're trying to stay relatively close to the launch site. And then our main gives us a descent rate of about 22 feet per second, which is gentle enough to bring it back down safely. Each of these altimeters uses its own series of switches, batteries, E-matches, and black powder charges for a fully redundant system. We also have an integrated telemetry link on the telemega that will send back flight information while it is in the air, and also GPS tracking information so that we can help go recover the rocket then after launch. We've used both of these flight computers in a variety of weather conditions, from extremely cold temperatures to just last month at the Cloudbusters February Fun Fly, and also the extreme temperatures of the New Mexico desert, so we feel confident we can fly these in a variety of conditions. Our ground station also consists of a teledongle connected to an Aero Yagi antenna that we'll use to obtain that in-flight telemetry, and that will then be processed by the Alt-OS software program. It'll not only give us that information while the rocket's in the air, but then also use that for recovering on the ground. We're also doing a variety of testing both on the ground and in the air. On the ground, we're doing deployment and testing of our drogue and main parachutes. This is to confirm not only that we have successful shear through of the shear pins, but that the parachutes are also released from the airframe properly. We're also doing indicated radio signal strength so that we can confirm that we have healthy telemetry data coming from a variety of orientations that the rocket may have once it's landed on the ground. We're also doing an in-flight test to confirm the functionality of our avionics, as well as the telemetry that we receive and successful deployment events of all of our parachutes. That'll be just before the Argonia Cup, and that will be our final checkout to confirm that all parts of this are successful. For securing our golf ball payload, we are taping it to a section of main parachute shock cord. This is really straightforward, but it has been proven for us to be successful in years past, and is one of the most lightweight solutions for keeping the golf ball maintained with the rocket, so that it descends along with the rest of the rocket and will then be recovered, hopefully as close to the launch site as possible.
Thank you for watching our video. We are excited to see how this competition turns out and cannot wait to be in the Cloudbusters Rocket Pasture at the end of this month. We would like to thank our sponsors, the OSU Student Government Association, the OSU Seat Student Council, and the Oklahoma NASA Space Grant. Without them, this competition would not be possible for us. And please check out our social media and go Pokes!
Yay! And that's a wrap.